Okay, so here we're going to look at free radical substitution reactions, and this is probably the simplest free radical substitution reaction you can have drawn here. So you've got methane reacting with chlorine, and the substitution is because one of those hydrogens is replaced with a chlorine in the final product, and the hydrogen that comes off also forms hydrogen chloride gas. So it's essentially always you're swapping a hydrogen for a halogen atom, chlorine in this case. So this is the way that haloalkanes are made. Right. To talk about how this happens, we need to just briefly say what a free radical is. A free radical is when you have an unpaired electron. So if you think about all the things we've come across so far, electrons always come in pairs. They're either in bonding pairs or they're in lone pairs. So if you've got ammonia, yeah, we've got 3 bonding pairs, and we've got 1 lone pair here. The electrons are always paired up as nitrogen. Okay, so in order to get this reaction going, you need energy in the form of UV light. So UV is needed here for it to happen. What UV will do is it breaks the chlorine-chlorine bond. Okay, the chlorine-chlorine bond isn't that strong as covalent bonds go, and there's a pair of electrons in it. And what happens? One chlorine takes one, and the other one takes the other one. And I haven't drawn the other electrons in the outer shell of the chlorine, but of course they've got 3 lone pairs as well. Each chlorine's got that. These species with an unpaired electron, these are free radicals, and they're very reactive, and they react and they make sure that their unpaired electron gets paired up. Okay, so these 2 chlorine radicals, which are made by breaking up the chlorine by UV light, can then react with the methane. So I'm going to draw that. I'll draw methane here. So we've got 4 bonding pairs. Okay, along comes chlorine, the chlorine free radical. Right, and it's got an unpaired electron. So what it does is it grabs hold of that hydrogen and takes the hydrogen with its electron. So they're going to form a new hydrogen chloride molecule, which I'll draw and stick with the colors. So I'm going to have chlorine there, and have my blue hydrogen here. But the hydrogen came with one of its electrons. Missing an electron off the chlorine there because it's free radical. And the chlorine, so there we've got a new covalent bond between the chlorine and the hydrogen. We formed HCl. But you also appreciate what's going to be left over is this thing. Squeezing my hydrogen there. Right, so these bonds were unaffected. All of these 3, they're okay. But you've got an unpaired electron here. So you can see that I should really draw that as a cross because I draw the dot leaving, okay? This thing here is a free radical. So this is very reactive. And you would normally write that down as CH3, and you put a dot. The dot shows that it's got an unpaired electron. You can write it like that as well on the top right, but I think it makes more sense to do it that way because it shows the unpaired electron is actually on the carbon. Okay, so this thing is now going to react with, it's going to be very reactive, and it's going to want to react with, and it will react with a chlorine. Okay, so what happens with that now is, I draw a chlorine. So this is a diatomic chlorine. This diatomic chlorine. That will then, right, so this free radical is going to grab hold of the chlorine, and it will take that electron there, this one here, it will take it to form a bond. So sticking with the same color scheme, that's going to give us, right, we're going to have the remainder of the methane here. But this is, so this is, these have been unaffected, these three hydrogens. This carbon, there's the electron that was left over in the free radical, but it's now formed a bond with a chlorine. So we formed chloromethane, and it won't have escaped your attention, I'm sure, that what have we also got left over is the other chlorine that was in this Cl2 molecule here. The other chlorine is now going to be a free radical. So we've got this. So we've got back to square one, really. We've regenerated another chlorine free radical, just like we had up here, that started off the whole process. So you can have this chlorine can then, this chlorine free radical can then do another cycle of substitution. So just draw the dot cross diagram so you can see what happens to all the electrons there. But in an exam, you wouldn't write it down like that. You would just write it in equations, as I'm going to show you now. And these steps have got names, and I'll name them. So the first step, where you've got chlorine and you have the UV light to make the two chlorine free radicals, that is called initiation. Okay, that's initiation. And then the second step, when the chlorine free radical reacts with the methane, so there's my chlorine free radical, it forms a methyl free radical, so CH3 with a dot on it, and it forms HCl. Well, that is called propagation. Now, in a propagation reaction, you get a free radical reacting with a non-free radical to make a new free radical. So we call that propagation 1. Then you can get another propagation reaction where the methyl free radical, so free radical reacting with something that's not a free radical, so Cl2, that's going to form CH3Cl, and you get another free radical. So that's also a propagation reaction. So you think, well, where does this stop? Well, you can see essentially this chlorine free radical, it's acted as a catalyst here because it's used up, but then it gets regenerated. So one chlorine free radical could go and replace, theoretically thousands and thousands of hydrogen atoms. And so, and that's what happens. So if you shine a UV light on a gas jar of chlorine and methane mixed together, the reaction goes so fast it's explosive because of these extremely quick reaction. Right, so how does it ever end then? How does it ever end? Well, it ends, and you might have guessed how it ends, is when you get two free radicals together. So imagine you had X was a free radical with a dot, and this X was a free radical and I had a dot. If these two react together, then you would form a covalent bond between the two X's. And that reaction is called termination. So there's a lot of different termination reactions are possible. For example, you might have a methyl free radical, so it's draw some possible terminations in do it in blue. You might get a methyl free radical and a chlorine free radical. What would that form? That would form CH3Cl. Or you might get two methyl free radicals. And that, you can see you form a new bond between the two carbons. So, should put the dot on the carbon there, really, shouldn't I? Put it over there. Then you'd get ethane, sorry. So you've actually made a new carbon-carbon bond. So that's another possibility. So any termination, like where you get two free radicals, which come together. So let's think: have you had your mixture of? Here's your mixture of chlorine, and you've got methane in there. Well, what would be the products? Well, you're always going to get HCl, aren't you? Because when the hydrogens get swapped, they join up with the other chlorine to form HCl. You could get some CH3Cl. You could also then replace two hydrogens from the same molecule, and you'd end up with CH2Cl2. Or you could replace three hydrogens, and you could end up with trichloromethane. Or you could end up replacing all of them and end up with tetrachloromethane. And then you could even get some larger molecules, couldn't you, like ethene, C2H6. And then I suppose those, the C2H6, could then undergo substitution. So you end up with a whole mixture of stuff. Is there any way of controlling what you get exactly? Well, you always will get a mixture, but you can probably guess. If you want to get mainly this one, you would probably want to use a high ratio of methane to chlorine. So you haven't got that much chlorine about, so you only tend to replace one hydrogen. Whereas if you wanted this one, you probably want you would want a high ratio of chlorine to methane. You want more chlorine, not very much methane, if you want to get that one. So you could control it that way. So the exam questions they ask you are always the same, really. The only difference is they might say, instead of we've used methane and chlorine to produce chloromethane, HCl. But they might say, right, you've got methane and you produce dichloromethane. So you're going to get two substitutions. So that would mean you pulled off two hydrogens from it. So you need a 2 in front of that, wouldn't you? So that means you'd need a total of 4 chlorines. You'd have to put a 2 there. Or they might say you've got ethane, C2H6, and you're reacting that with bromine to form C2H5Br, and you form HBr. So they can ask it in a number of different ways, but it's always essentially the same thing. Or they could, there's quite a lot of them where they said, right, you start off with CH3Cl, and you're going to turn that into CH2Cl2. Well, you put a chlorine in there, you're always going to make a hydrogen halide, HCl in that case, and you're only replacing one hydrogen there, so you would need yeah, that's balanced, isn't it, as it stands. So yeah, this one is the most basic, but they can ask several variations on that. Just change the alkane, or change the halogen, the diatomic halogen. And the importance of this, of course, is to make haloalkanes, and haloalkanes are extremely important in making organic molecules, in organic synthesis.